Okay, so we're going to be doing trigonometry, and what we're going to talk about is the four quadrants on a Cartesian plane, or what you guys use for graphing, and we're also going to talk about the Caste System. Okay, so what they have here is they call this your first quadrant, second quadrant, third quadrant, and the fourth quadrant. Okay, and Caste, C-A-S-T. And what these stand for is which of the ratios, we're usually working with either sine, cos, or tan, are positive in that quadrant. Okay, so for instance, S is the S here, so sine is positive in this quadrant. Okay, cos stands for the C here, so if we have an angle in this quadrant to the equation of cos, then it's positive. Obviously tangent is T, and the first one means all of them. That's what the A stands for. So C-A-S-T. So any angle in this quadrant, whether you're using sine, cos, or tan, will be a positive answer. Okay? In this quadrant, cos and tan will both give you negative answers. Okay? Sine is the only one that will give you another positive answer. So when we're doing our angles, for instance, when we're looking at this, we have different types of ratios. Let's say we're doing our special triangles. When we do our special triangles, I know these aren't quite the right numbers right now, but let's say we have something like this where we have 30 degrees, and they want to know when sine 30 degrees will give us a positive answer. We're talking about 30 degrees here, and we're also talking about 30 degrees over here. Okay? Now, so what that's going to mean is we're going to have a 30-degree angle, and then, of course, this is a 90-degree angle here. Let's put that up. So we're talking about a 90-degree angle. Sorry, not 90. A 30-degree angle, and starting from 90, or you can actually start from 180 over here and subtract 30. It's up to you how you want to do this. The other angle we're talking about will actually be 60 plus 90, so we're looking at 150. Okay, so we're either looking at sine 30 degrees or sine 150 degrees. Okay, so with that being said, we'll show it on a calculator. 30 degrees sine gives us positive 0.5. 150 degrees sine gives us positive 0.5. Let's keep going with that. Let's say again we have 30 degrees, and again we would make a triangle that looks roughly like this. I know these measurements aren't exactly perfect, but that's our 30 degrees, right? So let's use different colors here. This one's 30. This guy to here is technically 150 degrees. This guy to here is 180 plus 30. So do you know what that is?
210.
Yeah, 210 degrees. And finally, our last special triangle that we could possibly make here, this being 30 degrees. Do you know what this one would be?
30 plus
270 down there. Oh, sorry. No, technically plus. And this is 360. Think of it like 360 subtract 30. So we're talking about 330 degrees. Okay? So let's use those numbers. We've already used 30 and 150. 210 sine still gives us 0.5, but it's a negative answer, right? And that's the quadrant we're in. In the third quadrant, we know sine won't give us a positive answer. And 330 sine still gives us 0.5. So the absolute value of the number is always the same because we're using 30 degrees increments in terms of this. But we get negative answers when we're in the third quadrant and the fourth quadrant because we're talking about sine. We know sine is not positive in those quadrants. Okay. Had we done the exact same numbers, but say we use the cos ratio. Okay. So the cos ratio, 30 degrees cos, 0.86602. Okay. So it gives us that answer. 150 degrees cos. Same absolute value, but a negative answer because it's in the second quadrant. And the second quadrant, sine's the only one that's positive. In the third quadrant, we have 210 cos, same absolute value, still negative because tan is positive there. And 330 cos gives us a positive answer because that's our C. Quadrant 4 is the quadrant where cos is a positive answer. So these give us different options in whether we can get positive or negative answers. So, for instance, one of the questions you have down here is that gives two possible values of theta to the nearest degree, where theta is between, two possible values of theta, where theta is between 0 degrees and 360 degrees. Okay. And in this one, they've given us sine theta is equal to 0.5761. Well, what's important here is this is a positive answer. Okay, so we definitely know in the first quadrant it's going to be positive. We'll make a small Caste system here just so we know. Okay, so we know in the first quadrant everything. In quadrant 1, quadrant 2, it's just S. Quadrant 4 is C, AST, and this is quadrant 3, right? So because sine's positive, we're actually going to be working with either quadrant 3, wrong one. Sorry, quadrant 2 or quadrant 1, okay? Because that's the only two where sine is a positive answer, okay? So when we go to solve something like this, on our calculators, essentially think of it like bringing sine to the other side. So sine inverse of 0.5761 degrees, ratio. We plug this in our calculator, and we get 0.5761 sine 35 degrees. To say it around in this one, we'll go around, okay? Just say it's 35 degrees. So approximately 35 degrees is theta. So that would be in quadrant 1, right? We know 35 degrees falls in that quadrant, so we got that one checked. We need to find 35 degrees down here in the second quadrant too. So in other words, what do we have to do?
235 plus 180.
Plus 180? Okay. Let's try that. Bring up that calculator again. 35 plus 180. Are we in quadrant 2 at 215? No. How would we stay in quadrant 2? It wouldn't be plus 180. It'd be 180. Subtract 35. And the reason for that is because 180 here is the end of quadrant 2, and the 35 degrees is going back from 180. So that's going to give us 145 degrees. Okay. So that should be our other answer, 145. So this or 145 degrees. Let's make sure. Right? And these are both between 0 and 360. Okay. The reason they tell you between 0 and 360, even though they don't really talk about it, is because what you technically could do is be at 35, and then you could come all the way around. Oh, I didn't know that was going to happen. Let's try that again. 35, and you could come all the way around again, and 360 plus 35, you get another positive answer would be 395 degrees. But we only really work between 0 and 360 here. Okay? So let's test that answer. How we can check is sine 35. Let's see what it gives us. 35 sine 0.573. Yeah, so because we rounded, we didn't get exactly what they had here. But 0.57 is close. And let's see if that value, 145 sine 0.573. Yeah, so those are the two approximate angles we're looking for when we're looking at this question. So your next question stated you had a point at -4 and 9, and they wanted you to find, it's in the standard position, and they wanted you to find two angles out of this. This angle being theta, and this angle here being beta. So we turned it into a triangle. And we know measurements of the triangle. We know that the base of the triangle is actually a length of 4, right? And we know the height of this triangle is a length of 9, which is great. Now, when we go to solve this, okay, what this is, this theta here, is because remember when we talked about, I guess I'll have to try to do it with, say we had a triangle like this, say this was the angle we're looking for, well, if it had been 35 degrees, well, that same angle like this would be 35 degrees, right? So even though theta itself isn't going to be 35 degrees, it's going to be in reference to an angle that is the same as our beta here, if we were in quadrant 1, even though we're in quadrant 2 right now. So what we're going to do is kind of make up an imaginary triangle that mimics what is going on here. Okay. So this imaginary triangle here, we can set up, and we'll do this, and we'll do it in blue. Here's our beta. Well, we know this height again is 9, and this is still 4. They want the primary trig ratios. Okay. So we have this in quadrant 1, right? Because we're doing the primary trig ratios, we deal with them when they're acute angles. We're always talking about acute angles. We know this is going to be a right angle, the right angle triangle. So what they want is they want sine, and because this theta is technically related to this beta here, they want sine, you call it theta instead of the b, is equal to, they want cos theta is equal to, and they want tangent theta is equal to. Well, we know sine is equal to opposite over hypotenuse, right? Well, I have our opposite, we don't have our hypotenuse. So we're actually going to have to go about solving the hypotenuse of this, which means we call in Pythagorean's theorem. A squared plus b squared equals c squared. Work on it. So, our a squared is 4, our b squared is 9, and our c squared is our radius. We've got to find that. So 16 plus 81 equals c squared. 97 equals c squared. Root of 97 is c. Is this making sense? 97 root 9.48, I guess we'll call it. 9 point, no, that's not right. 848? Yeah. 84, I think it's actually 9. Okay. So 9 point, this distance here is 9.849. This distance. So when we go to set our primary trig ratio, it's opposite over hypotenuse. So we're talking about 9 divided by 9.8. So 9 divided by 9.849. Cosine is adjacent over hypotenuse. Adjacent is 4 over 9.849. And tangent is opposite over adjacent, which is nice because they've already given those to us. It's 4 over 9. So those themselves are the primary trig ratios. That's what they want you to solve when they say that. And then they'll tell you after to solve theta, which means you could use any of these 3 to solve for theta. You just bring it over and make it the inverse of it. Okay? So, or tan to the power of -1 is the idea.